All right, everyone. Thank you for joining us today as we are presenting to you about deploying a practical YAML build pipeline for AKS. I am one of your presenters today. Again, my name is Ryan Uruho. I'm a principal consultant at Innofactor Norway, and I specialize in providing customized solutions in the Azure cloud for my clients across the Nordics, sometimes Western Europe. And my focus as of the past couple of years has been in automation and Kubernetes. And I am here co-presenting with Marie.
Hello, I'm Marie. I'm a junior consultant at Innofactor Norway. I started working in IT quite recently, and I've been working mainly on technical documentation, automation, and Kubernetes in Azure.
All right, thank you, Marie. And today, again, presenting to you practical YAML build pipeline for AKS. Because of the nature of this content, as we were building it, we were realizing how dense the content could become. So from the get-go, we are providing you the content before we even give the presentation. It is already online and available on GitHub under Starkfrill IAMConf 2020 AKS Practical YAML. The entire demo we're providing to you today is already free for you online to unpack and tear apart and explore at your disposal. Additionally, we also recommend that a lot of the content that we're going over here, since it's more advanced, it's building upon a lot of the content on the 100 days of infrastructure as code in Azure. And in particular, we've included the days at the bottom that we highly recommend you read if you want additional supplemental information. If some of the content we're going over seems challenging or you need more information, we've included that for you here. So before we dive straight head into this content, we want to quickly discuss why YAML pipelines. So with YAML pipelines in Azure, it essentially allows you to completely control all resources, how they're deployed and managed and maintained in your Azure subscription or subscriptions as infrastructure as code. And it allows you to control this from a single location in a way that is completely trackable through any commit changes that are made to the repositories that are associated with the project that you're working on and where you're storing this information. Some of the pros and cons of using this paradigm, the pros are pretty obvious. You have complete management and tracking of everything that's going in your Azure subscription. And you have the ability to use just about any type of tooling you want to use to implement this. Anything from Azure CLI, ARM, Terraform, Bash, Python. If you want to use some other type of scripting or programming language, you could actually do that. You just have to make a wrapper for that particular tool you were trying to use. The cons about this is that it does have a pretty high barrier to entry, and that requires a good bit of time to get used to using the tools and troubleshooting your work and getting something in place. And it does require a code-based background and or related skill sets, at least scripting, to really take advantage of what's going on. Depending upon your environment, the amount of code maintenance is going to be dependent upon how you decide you want to implement this in your environment. If you have environments that are very static, that don't change very often, it's very possible that you're not going to have to change a lot of code very often. However, if you're tearing down and redeploying environments on a regular basis, you're definitely going to have to take the time to really think about how you want to construct and design your code to make it run in a build pipeline to ensure that you're not having to constantly babysit it. So what we're going to cover today, or in particular with this deployment that we're presenting to you, we're first going to deploy a management service principal. This is just a service principal that's going to essentially have full admin rights to the Azure subscription that we're managing. And it's going to have certain specific Azure Active Directory rights to allow it to create additional service principals in the environment. Additionally, once that piece is done, we're going to create a YAML build pipeline. And then from there, we're going to start tacking on certain bits or adding tasks into our build pipeline to deploy the following infrastructure, which includes the AKS Cluster, the PostgreSQL Server and database, the Azure Key Vaults that are involved with this deployment, as well as a small, and we mean this, very minimal Spring Boot app. It just demonstrates exactly what we're trying to get across. So don't get excited about the app. At the end of this, we're also going to verify access and connectivity to these resources, in particular to the Spring Boot app and its connectivity to the PostgreSQL Server database that's running in Azure. So to just illustrate this overview real quick, we have this one image here we wanted to present to you. You'll see that we'll be making all the changes in Azure DevOps, building our pipeline out. And as you see in front of you in the image, you essentially have an overview of the image of the actual resources that we'll be deploying in Azure. This is kind of the base overview of what everything will look like in the end. Now that we have that covered, before we go deploy our management service principle, we just wanted to show you that we have actually pre-populated everything for this demo in regards to the repository itself into an existing project, which we call Demo AKS Practical YAML. Within our repo here, we have cloned in essentially the presentation we're giving to you now, what's on GitHub, because this includes all of the code that we need to run this actual demo. Additionally, we're just showing you real quick that our Azure subscription is completely empty and essentially ready to go. So from this point, I'm going to actually run this prerequisite script to deploy the management service principles. And while I'm doing that is I'm doing that from an Ubuntu host, because this is a bash script and it's just going to work much quicker for me in this particular instance than if I would try to use something like PowerShell, although you could use PowerShell to do this if you really wanted to. Again, on my workstation VM to complete this task, I've cloned the same repo from the project into here. And I've already made sure that my script is executable. And before I execute it, there are some static variables that I'm setting ahead of time. And these static variables are essentially setting up the naming convention for my service principal, the Azure location where I'm deploying all of the resources into my subscription, the tenant ID, the subscription ID, and then the base name I'm using for the actual AKS cluster when we get to that point. And so once that's in place there, I am going to copy and paste in here some code where I'm populating properties for the actual service management deployment script. And I'm going to run this now. It's going to prompt me to log in. And I am logging in right now through my account for the Azure subscription. All right, so far, and this should kick off here in a couple minutes. And when it is, Marie, there are some things you wanted to tell our audience, I think.
Sure. So for our deployment today, we need to use a user account that has owner rights in the Azure subscription and global admin rights to Azure Active Directory. As I speak now, we are deploying a service principal that has full access to the Azure subscription, and that can also create additional service principals in the subscription. By using a management service principal for this type of access instead of a user account, we are able to ensure that the service principal acts as a service account and has limited rights to our environment. If we were to use a regular user account, there is potential for someone to maliciously take over that user account or for loss of access in a situation where someone would leave the company, for example. Another reason to use a management service principal is that it is common for people to have access to different Azure subscriptions and or Azure Active Directory tenants. So by using a management service principal, we are ensuring that we are not granting any additional permissions outside of the Azure subscription. Also, as a side note, you should know that you can restrict a service principal to only have access to specific resource in Azure. such as resource group, storage accounts, etc. So you can see it on your screen. The management service principal we use is going to create 3 extra service principals. The first one is a service principal for the Kubernetes cluster. That service principal is going to have access to the cluster resource group and all the resource within it, that is load balancers, static IP address, etc. We are also creating 2 additional service principals, the API CLI and API SRV, to facilitate authentication to the AKS cluster through Azure Active Directory. We can have a look at our deployment now, which is probably complete. Not quite yet. Maybe we can move to the Azure portal already and see if something's happening.
And real quick, guys, because we discussed earlier if it'd be easier if we were just working from one workstation, basically someone demoing and the other one helping to comment and walk through. That's why it's running from my desktop. So we apologize for not telling you that sooner. Marie, I'm sorry, forgot about that. Go on, Marie.
Yes, Ryan, maybe we can, we have the resource group here, so we can click into it. In that resource group, we have the key vault. If we look into the key vault and then look into our secrets here on the left, we can see that we already have the credentials for the service principal. And now we can also go to app registrations, maybe. Click on our service principal name. Okay, here it is. And click on API permissions. Now we can see the 4 permissions we want to grant to our service principal for it to be able to create the 3 other service principals we need. These permissions were populated in here from a JSON file in the prerequisite script directory. You can see it on screen. Okay, so now that the management service principal is in place, we need a way for Azure DevOps to have access to the Azure portal. By the way, I forgot to mention what you have here on the terminal. You can see 6 pieces of information: subscription ID, name, service connection name. You want to keep that terminal window open. We're going to use it right now. So I was saying we need to create an access in DevOps now. So we want to go to the Azure DevOps portal. We can click on our project, then create a service connection to Azure Resource Manager. And we want to authenticate using service principal manual. So we are leaving the environment set to Azure Cloud, the scope level to Azure subscription, and we simply have to copy and paste the subscription ID, name, password, and fill these required fields using the values still displayed in the terminal. By the way, we decided to use a service connection name that is identical to the name of the service principal that we just created earlier. You can use another name, but we recommend keeping it as simple as possible.
That was a typo on my part, or copy paste. All right, we're set. Maria, wasn't sure, is there anything else you wanted to add?
No, I was done. I was about to say that you can take it from here and start building the pipeline. Thank you.
All right, thank you, Marie. All right, so now that we have the actual service connection in place and we're authenticating to the our Azure subscription using our management service principal, again, just showing that to you over here, we can go ahead and build our pipeline. And to start with here, we're going to add in a very simple task that is actually not going to do a whole lot other than to just verify it works. And what we're doing is we're pulling in from the existing repository here, and we're pulling from an existing YAML file. And that YAML file is deploy Kate Spring. And we're going to continue to add tasks to this as we build our pipeline out. And in here, all we're doing basically is defining to trigger this pipeline anytime there's a commit to the master branch of this repo, which by the way is what we're working in down here. We're working on the master branch. And then we're going to run all of our tasks on the latest Ubuntu Azure DevOps Linux agent that's available out there in the cloud. And the first script here is just, this script to echo out some text and a goofy display name. And this job will take all of maybe 10 seconds to run. And while that is actually going on, we're going to go ahead and discuss the actual meat of this deployment, which is the actual deployment of the AKS cluster. We made available to you in this a way to basically go through and you can do with whatever you want with these pipelines or this repo after the fact, mainly because there's a lot to unpack if you're actually building something that is practical. Practical as in the scripts that are in here and everything that is built is reusable. It is idempotent, and you could implement it in your own environment if you wanted to. And so for our first script, our first task, I'm going to add in here deploying an AKS cluster. And actually, before I do that, I have been reminded that I need to rename this pipeline real quick. The pipeline is going to take the default name of the repository here, and we're going to rename this deploy Kate's Spring, just for ourselves. Back to the actual deploy Kate Spring, our YAML file here that we started. I'm going to paste in this piece here, and I'm going to explain what's going on here in just a minute, since it's going to take 6 to 10 minutes to run. In order to get this build piece started, I'm just committing it in. And I'm going to kick off this actual deployment now. I'm going to check the pipeline to make sure that it is, of course, triggering off the master branch as soon as I've made the commit. And it has. And one last thing I will check in here to verify before it's going on is I'm going to make sure that the authentication piece that starts at the beginning of this is actually working. We don't want there to be any issues with this, before we even get started. And so there we go. It's logged in as the service principal that we created for the service connection, and things are starting to deploy. So what's going on in this actual YAML part of the deployment? What we're doing is we're kicking off this particular script here, deploy-akskates-cluster.sh. And this script is actually part of several additional scripts that are used to deploy AKS and these resources that you see here for you in front of you in the image. So there are additional functions underneath the repo that are called by this script. And each of these subscripts is responsible for deploying a specific type of resource, such as check resource group is responsible for deploying the actual resource groups that we're going to create. Check ACR is specifically for the Azure Container Registry. Check Key Vault for the Key Vault, SSH keys for SSH keys, Cluster SP for the actual AKS Kate's cluster service principal that's required for it to manage its own resources. And then finally, the AAD auth script down here, which is responsible for the last two service principals that are needed to facilitate authentication to AKS through Azure Active Directory. Lastly, there's a last function in here that is specifically just for deploying the Kate's cluster in and of itself. Now, what we've done here is to make it easier to actually deploy a cluster rather than providing several parameters that define the actual definition of the cluster. We've instead decided to basically use a manifest. This manifest is just something we've made on our own that we can ingest values into. And in this case, we're setting up things such as the admin username for the actual nodes on the cluster, the name of the node pool being deployed, indicates version being deployed, how many nodes are running, disk size, and the node VM size. What this allows us to do is that if we wanted to deploy a cluster that is somewhat identical or somewhat similar, we're not having to mess around too much with any additional parameters that may need to be passed in a standard script here, like we have here. Instead, we would just have to point to the different JSON file for the respective environment we're deploying into. So this is why we decided to provide this, this example for you to do something like this, where you could deploy the cluster. While this is going on, let's go ahead and check our deployment and see what's going on right now. And so we see that the cluster is being deployed right now. All the resources that we had mentioned before are working fine. By the way, we know about this authorization request denied. That is something we're still working out, but it does not block the demo and does not block this actual, this deployment from actually working. While we're in here, we want to go ahead and check in our Azure subscription. And I'm going to go to the resource groups now and see where everything is actually coming into place. So we see that our main resource groups are now in place. We now see that our app registrations have been updated. We have them for our environment here, for IAM Spring. And the Kubernetes service should be actually kicking in here very shortly. And again, this is going to take a few more minutes to actually deploy before it's done in place. But yeah, it's creating right now. So everything is on the move. Now, one thing I wanted to mention in here in regards to this, was pretty sure that there were going to be questions later on about, well, Ryan, what do I do if I'm deploying a private Kubernetes service? You know, what may be some of the things you want to be looking for if you're deploying an Azure, a private cluster? Well, some of the things that we're taking advantage of here may not be available to you, such as a public IP that would be deployed with the cluster immediately. So you'd have to essentially tool your deployment around the fact that you don't have internet access for your cluster by default, which means that in this case here, you know, we're using in our deployment, or our YAML file, we're using an Azure DevOps Linux agent. For a private cluster, you're going to have to use your own hosted agent in your own environment. That's going to be running preferably on the same VNet as the actual AKS cluster, or on a VNet that has access to the VNet that the AKS cluster is running on privately. So there's a lot that you have to think about in regards to things that you take advantage of that are publicly accessible from just deploying a cluster like this, that you have to make everything localized for you in your deployment. And that's just one of the things to keep in mind out there. All right, we'll check our nodes. And when we did this deployment, we wanted to make sure we didn't have a horrible naming convention in regards to IAM-Kates or to the actual nodes resource group. By default, when you're deploying AKS in a cluster through the Kate service, unless you turn on the AKS preview option in the Azure CLI, you're going to get this horrible named resource group that's going to host your nodes. The AKS preview extension enabled, you can name the actual resource group where your nodes and load balancer and all the other resources are going to be running in. So that's why we have this nodes resource group here. And wow, that was nice. 5 minutes, 49 seconds. That's the fastest it's ran today. So now that that's done, we've deployed our cluster, but we technically don't have admin access to the cluster through Azure Active Directory. We technically have access using the AKS Git credentials and directly to the cluster, but we need to add in cluster admin access to the Azure CLI, through Azure Active Directory. So that's going to be the next piece we're going to add in here. And I'm going to kick this off here in just a second. Save, commit my changes. And kick off this deployment. And verify it's actually running here. All right.
Okay, well, while it's running, we can maybe have a look at the parameters used for this script.
Yes, absolutely.
So as you see here in the -d parameter, we have a comma-separated list of email addresses of the users being added to the cluster admin role in the Kubernetes cluster. In our case, to make it simple for this demo, we added our 2 mail addresses, but you could also use Azure groups or a JSON file if you want to have a longer list of cluster admins and or another way to manage them.
All right, thank you, Marie. And just like that, our cluster admins piece of the pipeline is working. And there we go, we've been added. And now we just need to verify it's actually working. So I'm going back to my Ubuntu Linux VM. I'm going to log into Azure again as myself. If you're wondering why I'm having to log in again, that service principal script is set up in such a way so that if someone else were to use that manually and you didn't need to have access to their rights, or to ensure that they had, say they had God mode rights and they accidentally let themselves logged in, you couldn't do anything silly behind them. That's why there is a log out piece that takes place as soon as that script is finished, which is why I'm having to log in again. And because I have access to multiple Azure subscriptions, I need to set the subscription I'm working with, and I'm going to be using the static variable I set earlier when we started this deployment to actually set that. This may take just a second for it to refresh. Says it's logged in. There we go. And now we have set the subscription. And now we're going to retrieve our credentials. If you're wondering, I should mention I'm copying and pasting from the other screen where I have the 100 days, not the 100 days, excuse me, the actual guide here open. So I'm using the same commands in here to actually demo this. So if you're wondering if we're eating our own dog food, we are. All right, so now I have downloaded the kubeconfig file from the AKS cluster, and I'm going to set my kube control app locally here to point to it. How I'm doing that is I'm running an export of the kubeconfig environment variable, so that's pointing at the cluster admin kubeconfig file. In this file, you'll notice in here that we have a cluster certificate. We have a URL pointing directly to the actual AKS cluster. If this were a private cluster, this would be pointing at the first private IP address that is in use by the actual it would have the IP address of the master of the K8s cluster in your private environment. Either way, it's got to point to somewhere to hit the API of the K8s of the actual Kubernetes cluster. In this case here, it fills out the rest of the base context in here. And what's going to happen now when I log in to the actual AKS cluster, it's going to fill out the rest of the environment, the configuration information in here with my OAuth 2 token from AAD to authenticate. So I'm going to go ahead and force it to make me authenticate by running kubecontrol get nodes. You could run any kubecontrol against the cluster, and it's not going to detect unauthenticated, which is why it's pointing for me to authenticate again. And you'll see here that I am hitting the actual service principal that we created earlier for this type of authentication. And you'll see the other second service principal, the API SRV, that's in here too, granting access to it. We're going to consent on behalf of my organization and accept. And we can close this window, or I'm just going to leave it available for later, just in case. And you can see now I can get my nodes. I can also query the rest of the cluster. And then I can see, voila, pods and everything else is working. So we've configured access to our cluster. Everything is working on that front. The next piece here is we need to start deploying the actual resources for the PostgreSQL database. And the first piece we're going to do is we're going to actually deploy a key vault for storing our secrets, where we're actually, to place the source key vault to store the secrets that we're generating for the deployment of the PostgreSQL server in Azure. And let me kick this off now. And this will start running, and I'll verify that the actual pipeline is kicking off. And this will take a couple minutes to run, only because it has to go through the rest of the tooling in here, and then the actual deployment of the key vault will take maybe a couple minutes. It won't be too terribly long. I should note in here that if you can see in here, since it's highlighted, how we're making this easy in regards to using what may seem like a lot of actual code to run this is that a lot of these functions and scripts that are running in this repo, they use the same base variables for the naming convention and for the identification of resources that are being created in Azure. That's why, you know, if I'm adding a new script, for instance, where I wanted to add an event hub, the majority of the Azure CLI commands to run, like for instance, deploy an event hub, is almost identical to the rest of the other Azure CLI commands to deploy a resource group or AKS cluster or storage. I'm having a base coding to wrap that in, which I'm doing right now with Bash, enables me to essentially create something once and then take a little bit of time to retool it to use it to deploy other resources into Azure. So as you go through this, if it seems overwhelming, my recommendation would be to, you know, go through the functions first. Look at the smallest function, like, deploying a resource group, and look how small it is. And you'll see that these have followed the same type of pattern throughout to make them reusable and scalable in this particular manner. And this is something you could do with any other type of programming language-based scripting you want to do with this in Azure DevOps in a YAML build pipeline. And there's something you wanted to mention, Marie?
Yes, there is something interesting here. We could have mentioned that before because it's not the first time it happens. You've probably noticed that when you are creating key vaults in Azure at the moment, as of recently, the soft delete feature is automatically enabled. Soft delete ensures that if a key vault is deleted, that key vault will be visibly removed from Azure, but won't be fully deleted actually. For a period of 90 days by default, you have two options. Either you recover the key vault by running a recovery and retrieve secrets within that key vault, which could be really useful sometime, or you can, as we do here, purge the key vault so it's no longer recoverable in Azure. While this protection is really a good feature in general, if you happen to be redeploying the same environment several times over, it could cause your automation to break. For the purpose of this demo, we are checking all the key vaults we're deploying to see if they have been soft deleted previously, and if they are aware, we purge them before attempting to deploy them again.
All right, thank you, Marie. And I think we are, yeah, this is almost done. We can go ahead and check in the actual Azure subscription real quick. We'll verify that the pSQL key vault is in place. And you'll notice we have two key vaults here, one for storing the secrets of the server for the PostgreSQL server, and one for the databases. And before we get to that, there's something here I want to touch on in regards to access to the key vault, which I will mention here as soon as we kick off the actual deployment of the Postgres server. That will be the next piece that's running in here. And since this takes a couple of minutes, I'm going to make sure that this goes off before we continue discussing it. And in our pipeline here, all right, it's kicked off, so we can monitor the job from there. One thing we wanted to mention is that when I deployed this earlier, whether it's Maria or myself, and we're deploying a management service principal to the environment, whoever the first person is, or the person that's actually deploying that management service principal, they're going to have initial access to the actual secrets that are kept that are generated with that service principal. By default, they're giving access in the access policies and the key vault where those secrets are being stored. Likewise, since all of our deployments that we're running right now are being done by the service principal, no one except the service principal currently has access to the secrets. Now, this doesn't help, obviously, if you have global admin rights to the actual Azure subscription yourself, like Maria and myself do. However, it ensures that people that don't have those rights can't accidentally go around here snooping and looking at something they don't have access to. Just something that you want to keep in mind of how this acts as kind of like another layer of security, and the fact that if by deploying this by default in using this methodology, if someone was going to go to change the access policies in here, it'd be pretty easy to figure out who is doing it pretty quickly. All right, let's check our pipeline and look at the Postgres server. And we see it's starting to actually generate the password and everything else for the Postgres SQL Server. And Maria, I think there was something you wanted to mention about Postgres Server.
Mm-hmm. So as you see on the screen, we are using an IP address here, but by default, access to the Postgres SQL Server in Azure is going to be block outside access. So we've added our current location public IP address. You can see it on the screen, 213, etc., to the -s parameter in the script, but this parameter will also accept multiple IP addresses that are comma separated. You might also want to note that there exists the option in Azure Postgres SQL Server to provide an IP address range as well. That was it.
All right, cool. All right, and so our deployment is continuing right now. And if we go through here next, the next piece, we're going to be actually deploying the Spring app to our actual AKS cluster. Before then, there was something else I wanted to mention in here in regards to this. And when you're done seeing this presentation and you go in after the fact, there's something in here we don't have time to actually demonstrate, but we left it in here for you so you can play around with it. You have the ability to add a secondary node pool of your choice, of your naming at the end of this presentation or on your own with the actual repo. We included it in here just as something that we know that question seems to come up. It's like, how can I add my own node pool? How can I customize it? You know, how can I make it that more flexible for our environment? And voila, here's something that you can play with to figure out how you want to use that. All right, now our access is being added to the Postgres SQL Server. Let's go ahead and check on the Azure portal and verify our day SQL Server is in place. It is running. There is something we did here because when we mentioned that our Spring Boot app is minimal and it only does what we want it to do, we had to disable SSL enforcement to get this app to work because that's just how, well, let's just say it's not the greatest thing in the world, but it does its job, and that's all that matters for this demo. In general, you do not want to disable SSL enforcement, but know that you can. We do not recommend ever doing that in a production environment under any circumstance. If we go down here, we can see that the Spring DB that we wanted to demo is in place here, so that is looking good. So our deployment is actually finished. And now we can move on and add in our Spring app. So we'll go ahead and do that piece next and add that final piece in here. And again, as you see, we're just tacking on to our YAML build pipeline, because this is how you would actually build a YAML pipeline over a period of time. You would just be adding on additional tasks and or stages to your pipeline. And that's something we should note in here. If you want to, you can absolutely take a single YAML pipeline and you can set it up in multiple stages to deploy to different subscriptions or different locations. Because remember, this Azure subscription value that's used in each of these tasks here, it's referring to a service connection. It doesn't have any other identifying information of where it's actually deploying to. So if you have service connections to 10 different locations, 10 Azure subscriptions, you could technically deploy to 10 locations from a single YAML pipeline. They may not be the greatest idea in the world, but it may have a use case for someone somewhere. All right, so it's going through the process now of the idempotent deployment. Again, each time that this YAML pipeline is running, it's doing checks across the actual resources that were previously deployed to ensure that they were already in place. That's why they quickly go through and look, does it exist? Does it exist? Okay, continue, finish, get in, get out. There is one change or one thing here that isn't as idempotent as I'd like, and that is the force check to ensure that the IP addresses are in place for the PostgreSQL server. This is always, in this particular case, this script is going to force to always ensure that the IPs that should be allowed publicly are in place. And then finally, we can see our Spring app is actually being deployed, and it's actually being deployed out right now. Now, with the Spring app, the way that we've configured it to connect to our PostgreSQL server here is by using a config map. Within this config map, we are pulling in environment variables that we are setting on the actual Spring Boot app. But these environment variables are populated to the Spring Boot app from secrets that are in the namespace that the app is deploying in. This is a pretty standard secure way of ensuring that you're adding secrets that are only accessible on the AKS cluster by the app, only within the namespace that the app is running in. So it's a pretty standard way of actually ensuring that secrets are only being passed and used by your app securely in a AKS cluster. We're also replacing this text here, namespace and curly braces, and that's being replaced by the namespace. So we're deploying the actual Spring Boot app. In this case, it's just called Spring. Since the deployment is finished, we're going to quickly go through here and query the namespaces on the cluster. And we see that our Spring app is here. And just to show you, our Spring credentials are in place, the secrets that we were mentioning before. And we can actually see the Spring app running now. And within here, you'll see that it's listening on an external IP address, 51.105.196.114. If we go to our Azure subscription, we're going to browse to the Spring nodes resource group. And we'll see a new public IP address here. And we'll see the IP address that the app is running on. And you'll notice that it'll automatically tag the public IP address so that you know which resources in Azure specific apps are using. So if you're actually doing querying resources in Azure and you're wondering where something is being used in a AKS cluster, don't look for the naming convention here because obviously it is terrifyingly unfriendly. Look for tags. Query the tags in your resources, in your resource groups, and then look for the matching tags for the services you're running in your cluster. Now, if we go ahead, we're gonna, again, the 51.IP address here, again, seeing here, we're gonna go ahead and open this up in another tab. And there it is. We meant bare minimum app, we meant it, and it is working. And if you want to right now, if you're watching this, if you want to browse to that and hit it, feel free, go ahead. We're going to show you and prove to you that it's actually connected to a PostgreSQL server right now. For giggles, I'm just going to go ahead and type something in here. So we have a value in place. If someone else gets this ahead of me and they want to go ahead and type something else in there, that's perfectly fine. We're going to see it in a minute in the PostgreSQL server, or on the, excuse me, on the PostgreSQL database that the Spring app is connected to. So in order to query the pSQL server, well, the database, we need access to the secrets in the key vault, which I do not have. I have not granted access. So what I'm going to do right now is I'm just going to go ahead, since I have access to the secrets for the service, the management service principal, I'm going to retrieve them and log in as the management service principal right now. In general, this would probably not be a recommended idea of doing things unless you're troubleshooting, mainly because the rights are going to be granted by the service principal running as a service principal against your Azure subscription. And so I'm going to log in right now. And again, as before, I'm copying and pasting from the GitHub repo that we shared with you earlier. Now I'm going to retrieve the Spring database password just from the key vault. And now I'm going to query using pSQL the actual tables that are running. And there's a single table with a single row that's running in this environment. And all I'm doing here basically is, constructing the actual pSQL or connection string to query the database. To actually see the values that are running in place. Voila. Thank you, Manjit B. Good man. Perfect. And we can see here, he added something in here. We are good to go. And if I check again, everything is working as intended. So that is pretty much it for our session. We just wanted to show you again end-to-end AKS, end-to-end deployment with a build pipeline, deploying AKS and some resources in Azure, and how you could put this together yourselves, and also to provide you something to play with after the fact. So, Pete, are you around, sir?
I am, and we have many questions. Now, fortunately, I think we have a fair bit of time.
Yep.
So we'll make use of it. So the first question here, bear with me while I get the queue up again. Just refreshing here. What is the 100 days of IAC exactly?
Okay, good question. I should have mentioned that from the get-go. The 100 Days of Infrastructure as Code is a blog series that I put together with Pete Zerger, myself. I think Stanislav wrote on it, Tal wrote on it as well. For Kindern, I think as well. If I'm missing somebody, I apologize, gentlemen and ladies. That we wanted to provide essentially kind of a jump point for people to start learning infrastructure as code in Azure. And through the 100 days, you can find resources for basically getting started writing infrastructure as code, everything from building Yaml pipelines to, oh God, there's so much content in there. Pete, if you want to jump in
Ryan,
here.
if you don't mind briefly, just go over to the GitHub repo. Absolutely. And just show them what's there and how to navigate. And and then maybe if you could just put the URL into the chat.
Sure, absolutely. So we'll go over here, and where is chat?
Tell you what, I'll put it in there while you show them around. How about that?
Beautiful, sir. Thank you.
Mm-hmm.
So yeah, if you just go to the root of the actual repository, start on day 0 if you want, day 1, and we have everything from basically helping you to essentially get started setting up your development environment for working with infrastructure as code on Windows and/or Linux, recommendations from how to write, what tools to use, recommendations for using specific resources in Azure, and we just continually built on for 100 days building this up. And you'll notice that on the left side that we have kind of like a theme or a subject for each of the days we wrote about. And yeah, it's completely free, it's completely usable. And if you have any comments, questions, or would like to need anything changed or added, you can just simply open up a open up an issue and let us know.
There you go. And the next question, Ryan, will you share your repo URLs for the projects you showed us in this session?
Absolutely, it's right here. Give me that link to the chat window, Mr. I'll paste it in right here.
Yeah, let me, I'm just looking here. Why don't you send it to me, and you can do it down in the chat area there. For worst case, just send it to me and I'll offline and I'll paste it over.
There, I finally see it, sorry.
Okay, so if you were looking for the 100 days of infrastructure as code, that URL is in the chat window for all to see now.
Yep. Okay, no, it did take it. So there's that. Sorry, I didn't realize the chat window is going to wrap around so much.
Oh, gotcha. Yeah, there's kind
there
of a
it
small
is.
window.
Yep, and there it is. It's in there.
Okay, perfect. Thank you.
Yep.
Next question. Why did you choose shell script to deploy Azure Kubernetes service instead of an ARM template?
You could use either or. Perfectly fine. How you want to go about it. I like the flexibility that I get with Azure CLI and Bash, to be perfectly honest. There are things that I can programmatically replace values, for instance. Variables a lot easier using kind of a base template like I've been using in here. And then again, I can template easier for myself how I want to manage essentially how I'm deploying that cluster out and how I'm customizing it. It's entirely up to you. If someone wants to use ARM, if they're more comfortable with ARM, that's great. We used to, honestly, I mean, you could ask Pete, years ago, we deployed everything with ARM. As certain things started getting more complicated, our experience at that time was that ARM was not scaling in a more manageable way. So we've seen other people, they switch to PowerShell or they switch to Terraform or something else. I like Azure CLI because of essentially how it interacts with the actual Graph API and the Azure Active Directory Graph API. I can actually operate against the actual Graph API, the Graph API and the Azure Active Directory Graph API directly with the Azure CLI. For me, it's just more flexible. Just easier to read, easier to manage. To each their own, guys.
Yeah, and so just to pile on to Ryan's answer there, when we look at deployment methodology, so ARM templates are idempotent and declarative, right? So with shell script, with Bash, you're looking at the Azure CLI, and that is, the create command in Azure CLI are idempotent, but it's not declarative. So we found when we were creating entire environments that had where the cluster was but one piece, that what we couldn't get in terms of declarative deployment with Azure CLI, we could make up for it by putting it into our Azure DevOps pipeline, where we could use tasks and stages in our deployments to control the flow. And part of that was not just the fact that it was convenient in that way. We were also dealing with a group that hadn't really used ARM before and hadn't used Azure before, but they had used shell scripting extensively. So stepping into it with shell script was kind of a good middle ground where they could engage with us in Azure without having to become ARM template authoring experts overnight and learning a whole new language. So it became kind of a first step, and we did ultimately incorporate some ARM in there into the pipeline, but it's something to think about. You want to meet your team where they are, and getting to the top of the mountain maybe doesn't happen in your first iteration. Next question, would you create a separate repository for every cluster you want to deploy?
No, not necessarily. That depends. So if I'm looking right here, right? So it depends how your folder structure is set up for your environment. In our case here, honestly, Maria and myself, we ran out of time just because our eyes got bigger than what we could pull off, honestly, right? And if you wanted to, you could create another subfolder here. Sorry guys, it's not working for me real quick. Say I want to do something with AKS engine instead. Different type of cluster, different type of environment, right? And I could design an actual build pipeline, another build pipeline file in the AKS engine folder. And from there, essentially, I could have that part triggered off, say, a separate branch or the same master branch if I wanted to. You'd probably want to do it on a different branch. You have a lot of different ways of how you can split this up. So you could technically have everything in the same repo and then have your triggers basically customized to where you want them to trigger from. And then at the same time, in our actual pipeline here, you could just go through. Sorry, I need to minimize that real quick. I could go through here and just add another pipeline. I'm not going to run this because that would, well, it wouldn't do anything actually. I have no idea what happened to that pipeline, but okay. Say I have a starter pipeline.
So while you're looking at YAML pipelines, do you find YAML pipelines as easy to work with as the legacy visual option now?
Yes. Well, yes and no. There's still a learning curve there. So that is honestly up to you, basically. So at this point, because everything is moving towards YAML, I would go with YAML, honestly. You could, because there's so much flexibility in there, as well as the documentation is really good now on how to use all of the tasks. Unless you're using something legacy, that's the only reason I'd be using the GUI, honestly. And yeah, I don't know what silliness I'm running into here, but the point being is it's up to you how you'd want to, if you want to use multiple repos per pipeline, you can do that. Entirely up to you guys. If you have environments, for instance, say for instance you have clusters that you're like, this is for my one, this is for the Spring devs, and you have another cluster that say this is for the .NET devs. Okay, that may be a damn good reason to have two separate repos. Not necessarily because it's easier to organize, but it's to ensure that which environment you're working in does not accidentally impact the other, so to speak, especially when you're working with developers and build pipelines and infrastructure as code. You're going to run into the fact at some point that the developers are going to want something done that's going to bleed over between the app and the infrastructure, and you're going to have to build custom integration at some point. It may not be a lot, but it almost inevitably always happens.
There we go. Next question. Can a policy change the lock assigned on an individual resource? I think that's probably a better question for the next session, but if you want to answer that, Ryan, or I can answer that.
I don't know off the top of my head, sir. Honestly, I'd have to look it up. If you know, please take it.
Yeah, so that's possible, but let's park that because we've got Bert coming up with governance. We've got Steve talking Azure policy right after him. So I'll actually just pitch that out there before one of their sessions and make sure we get that illustrated hands-on. Let me see here. Bear with me.
No problem.
How are you managing the updates to your AKS clusters in Azure today?
Depends on the environment a lot of times, because as you saw in this demo here, all of the actual SQL servers, all of the stateful data is sitting outside the cluster. Instead of worrying about managing what's in that cluster, if the client allows downtime, I will just blow it away and redeploy it.
And so just to follow that up, Ryan, how do you deal with preserving data during that redeployment process? Maybe clarify that.
Yeah, well, depends on the environment. If you run into an existing client where they're using, for instance, say they decide that they wanted to use within the Kate's resource group, they wanted to add in their storage accounts here, and they wanted to have apps that are attaching to attached storage running in that resource group. Well, obviously, I can't do anything about that. And the way I would prefer to have it would be to have those storage accounts in a separate resource group that's outside of the main infrastructure of the Kate's cluster. So if it was possible to migrate it out, the app still works most of the time and the data stays stateful, I would move it out to a separate resource group if they're able to be migrated, tear down the cluster, redeploy. If you can't do that, then the updates you're going to have to use for AKS, it depends on the version of AKS that you're using. And you could do a kind of a rollover, rolling updates to your nodes if you're upgrading the actual cluster. And you'd be coordinating and draining your nodes of the apps and moving them between nodes as you're doing a rolling update. I'd prefer not to worry about it, which is why if I go to a client, I just try to get them to design everything stateful, stays out of the Kate's cluster, period.
Yeah, there you go. Okay, and follow up on that repository question. I'm asking about the repositories because I'm looking for ways to automate multiple environment AKS deployments for the same team and to give developers the possibility to modify the repository, add configurations, create pull requests, and trigger updates. So it sounds like a management boundary, yeah. Like we need different folks that have different scopes of control.
It does. I'd be happy also to take that offline and take a look at that question and respond directly to the attendee about that if you'd like.
Yeah. Hey Robert, I'm going to take that offline. I'm going to connect you and Ryan via email so you guys can chat about that at length. So you've got an interesting situation there for sure.
Yep.
So
no problem helping out.
We'll make that happen. And to follow up on that, talking about, how can you manage that, blow it away and redeploy strategy?
Mm-hmm.
At the end of the day, resource locks can prevent mistakes. But if you think about the deployment process, it comes down to identifying your what we call your persistent data. So my cluster in the Microsoft construct is really cattle, right? I can get rid of it and I can put it back there. And if I have the underlying storage where my application data lives, my databases, etc., I'm just fine. I have to redeploy those nodes. I might have to deal with, I'll have to deal with some endpoint publishing, depending on how my ingress works. But if my strategy is simply wipe the cluster rather than patching it, because the challenge right now with cluster patching in AKS is that like to your nodes, the patches come down, but it's up to you to reboot. So that's a bit of a headache, right? And it's not a surprise that Microsoft would leave it to us to reboot because they don't want to be disruptive to our workflows, and they can't possibly guess all of the ways we might have configured our nodes. And if we don't have enough capacity in there, a reboot could be disruptive, right?
Correct.
So,
there's something I want to add in there real quick, if you don't mind, Pete.
Yeah, go right ahead, please.
Yes. So thinking about this too, where you're put in these positions where you have things in your AKS cluster that or you find out later should not be running in there, or they were against something you didn't know about, or they were against your will, right? Your team told your developers or another team, you shouldn't be doing this, and they do it anyways, right? If you have the ability, one thing I've seen works very well. If I have a development team asking me for something, first question I ask is why? Especially when it comes to something running in Kubernetes, because since they're running everything typically on Minikube, they can do whatever the heck they want, and there's zero impact to any of the development they're doing, right? And so if they're testing, say, a new tool, say they're testing Istio on Minikube or something, right? They a lot of times will think that directly translate that's going to work exactly like it is in an AKS cluster, which it absolutely will not. It could be running very, very differently. So I would recommend also get good at asking why they want something, and then try to work out the issue before the issue occurs. Just something I wanted to throw out there.
There we go. Thanks for all the answers here. Let me see. Cured could be used to automatically reboot the nodes if a patch requires it. Yeah, that's true, Robert. I think the only reason they don't though is just because of the disruptive factor, right? So you could plug in Cured and take care of it. It's a good point. All right, so Rob, I'll connect you and Ryan, and you all can have a good chat. So Ryan, I'm going to take control.